In these examples, we're going to be taking the derivative of functions involving e to the x. From our notes and videos, we've learned that the derivative of e to the x is e to the x. So we will use that in these examples. Here our first function is f of x equal to 8 times e to the x. So here when we take the derivative f prime of x, we can carry that constant along with us, constant of 8. So we have 8 times, and then we need to take the derivative of e to the x. So we get an answer of 8e to the x, since the derivative of e to the x is e to the x. In this next example, part B, we have g of x equal to 2 times e to the 6x. So now in our exponent, we don't have just x, we have 6x. So now when we go to find the derivative of this one, we have to recall what we have it in our notes, where when we take the derivative of e to some function, so we have something, so in our exponent we have more than just x, we have some function. So in this case we can think of that function as 6x. Then to find the derivative, we take e to the function times the derivative of that function. So we can think of, we can just kind of copy down e to whatever that function is, but we have to then remember to take the derivative of the function. Alright, so to find the derivative of g, so g prime of x, we can carry that constant along with us. Now, taking the derivative of e to the 6x. So we have e to the 6x, and now we need to remember to multiply by the derivative of that function. So multiply by the derivative of 6x. Derivative of 6x is 6. So simplifying here, we have 12 when we multiply the 2 and the 6. So we have 12e to the 6x. Alright, so that is our answer for part B. Part C, we have the function capital F of x equal to 7 plus 3 times e to the negative 5x. So f prime of x then, our first term is 7, well the derivative of a constant is 0. Moving on to the next term, the 3 times e to the negative 5x. When we take the derivative, we can carry a constant along with us. Now we're taking the derivative of e to the negative 5x. Well, we know that using our formula here for taking the derivative of e to the function, so in this case we can think of our function f of x as the negative 5x. So our derivative then is going to be e to the negative 5x, but now we have to multiply by the derivative of negative 5x. The derivative of a negative 5x is negative 5. So we just have to remember that even though the derivative of e to the x is e to the x, if we have something more than just an x in our exponent, then we need to then multiply by the derivative of that exponent. Alright, so now simplifying, we have a negative 15 e to the negative 5x as our answer. Part D, we have capital G of x equal to x to the 5th minus 2 times e to the 6x. So taking the derivative of g prime of x, the derivative of the first term, the derivative of x to the 5th, using the power rule, we have 5x to the 4th minus, now let's take the derivative of the next term. We carry the constant along with us. Now we're taking the derivative of e to the 6x. Well, we know that that derivative is e to the 6x. Now we have to multiply by the derivative of 6x. So multiplying by the derivative of 6x, the derivative of that is 6. Now simplifying here, we have 5x to the 4th minus 12e to the 6x. Okay, the next example in part E, we have h of x equal to e to the 3x divided by x to the 6th. So here we will have to use the quotient rule. Notice we have a numerator and a denominator. So just recall what the quotient rule looks like. This is my shorthand notation here for remembering the quotient rule. We have the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared. So here when we go to find h prime of x, we have the denominator, which is x to the 6th, times the derivative of the numerator. So we're multiplying by e to the 3x, and then the derivative of the function in the exponent. So then we're multiplying by a 3. Minus, now the numerator, which is e to the 3x, times the derivative of the denominator. So the derivative of x to the 6th is 6x to the 5th. And then that's all divided by the denominator squared. When we take x to the 6th and square it, we get x to the 12th. Alright, so now let's simplify. We can factor out an x to the 5th out of the numerator, and that'll cancel out with some of the x's in the denominator. So factoring out an x to the 5th, we're left with 3x e to the 3x minus 6e to the 3x divided by x to the 12th. So now the x to the 5th will cancel out with some of the x's on the bottom, so we'll be left with x to the 7th in the denominator. So now we have 3x e to the 3x minus 6e to the 3x divided by x to the 7th. So there's our derivative of h of x. Now you could have factored out a 3 and the e to the 3x out of the numerator, and while it doesn't really simplify it much, it just makes the answer look a little differently. So if you would do that, then your answer would then look like, if we factor out a 3 and an e to the 3x, we would be left with x minus 2, all divided by x to the 7th. So here either answer is acceptable. For part F, we're finding the derivative of h of x, which is equal to the square root of e to the x plus 1. Well, I'm going to rewrite this, write it, make it look a little different, as e to the x plus 1 all raised to the 1/2 power. And that will allow us to use the power rule and also the chain rule. So here, to find h prime of x, using the power rule, we bring the 1/2 out in front, write down, just copy down everything in the parentheses, and then we're going to subtract 1 from the exponent to leave us with a negative 1/2 exponent. Now here we now need to multiply by the derivative of everything on the inside. Well, the derivative of the inside, the derivative of e to the x is e to the x, and then the derivative of a constant is 0. Right. So our derivative then looks like, we can rewrite this as e to the x in the numerator divided by 2 times the square root of e to the x plus 1. So I've made the exponent negative 1/2 positive by moving it to the denominator and then rewriting it as a square root. So there's our derivative of h of x.